Now, we look at convection. So heat energy moves through liquids and gases mainly by convection. Earlier, we were looking at conduction, and conduction is usually for solids. So let's look at how convection works. So we have a beaker, and inside the beaker you have water. Then you heat it up. So you apply heat here. So heat starts here. So the heat is at the bottom of the beaker. So the water at the bottom is heated. So when something is heated, it expands, volume increase, and the density decreases. Because the density is decreased, it becomes less dense. Yes? So it becomes somewhat lighter. Because of this, the hot water rises. Because it's less dense, so it rises. The cooler water, so the cold water that's really far away from the heat, is cold, right? Still cold. It moves down because this is denser. Okay, so in a way it's denser, so it moves down. The one that is less dense, because the density decrease, it moves up. So the cooler water gets heated up, expands, and the same process happens again, creating a cycle. So this is how convection works. Okay, so the circulation of liquid in this manner is called convection current. So convection current is when hot particles rises because it's less dense, and then cold particles sinks because it's denser. So if I have hot particles that becomes less dense and it rises, and then cold particles that becomes more dense and then it sinks, it creates this cycle. One sinks, one rises. When you have something like this, you get a convection current. And when there's a convection current, so you have convection happening over there. So this is the same for gases. Hot gas will rise, cool gas will sink. Okay, so basically hot air rises, cold air sinks. Okay, so convection doesn't take place in solids because the molecules in solids cannot move. Okay, solids cannot rise nor sink. So some examples of convection. So if we look at an electric kettle, the heating element where it gets heated, if you open your kettle, the heating element is usually at the bottom. It's put at the bottom so that you can use the laws of convection. Okay, so the water near the heating element will expand first and then rise upwards. Okay, so it expands first, rise upwards. This will produce a convection current that will heat up the water faster than simply by conduction. Okay, in a cooler, the ice or cooling element is always placed at the top. This is because cooled air or water will sink. So you want it to keep cold. So because the cold air will always sink, it'll go down. As it goes down, the heat, the warmer air, goes up. So this creates a convection current. So basically, when you want to use convection, you need to use the law of convection current. Same with air conditioner. So why do we always put our aircon up? Is because cold air will sink. You want the cold air. You don't want the hot air, do you? Okay, because cold air will sink, your hot air will go up. So this cycle will continue over and over again until your room is very cold. The same thing for radiator. So in Brunei, we don't really use radiator because this is to warm up a room, and Brunei is warm enough as it is. But basically, radiator is like an aircon, but instead of giving cold air, it's hot air. And usually put a radiator at the bottom. Okay, so it's the same principle as an aircon, but instead of releasing cold air, you release hot air. Because you release hot air, you want the hot air to rise, to go up. Okay, so if the hot air goes up, it creates a convection current. And that will warm up the room faster.